So what on 1.4, they call this a library of functions, and then they do some piecewise, what they call a piecewise function. Okay, so what it is a big collection of functions. Sometimes I call it like a toolbox or something like that. Library is a good word for it. It's a whole collection of functions. So what we're going to do is we'll go over those, kind of classify them, draw some graphs, talks about the domain and range. I might have to pop back and forth, do some Desmos stuff with you, okay, since I can't do that on here. So let's go ahead and talk about that. So we'll call it just, we can call it a library of functions like they do. That's not bad. So what's kind of helpful is that you're able to recognize the graph of a function and say, oh, I think I know what that is. Okay, so that's kind of the objective, is to be able to recognize what it is and then talk about some of the characteristics of it. So the first one we'll talk about is a linear, which is something you're probably really familiar with. All right, and the real basic general form of a linear is just y equals x. All right, now I know it's y equals mx plus b, but we'll get into that a little bit later when we talk about transformations. But for now, it's just y equals x. That's your real basic linear function. All right, that looks, oh, that wasn't very good. So it looks like this. Okay, so there's our basic linear function, and the domain and the range. Okay, so if this is a linear function, what's the domain? All real numbers, right? And what's the range? All reals. Okay, so then that's what we're going to put down here. So we're just going to go all reals like that. Okay, so that's our linear. No surprise there. Pretty straightforward, right? Then they have what they call like a power function. And they take on a number of different forms. So we have y equals x to the n is a power function, all right? So what we'll do is let's take a look at those. Okay, so if I go into Desmos here and I pull up my power functions, what we'll do is we'll introduce something called a slider. I just don't remember if we did any of that last week. We could have. So it's going to be y equals, I'm going to put an x to the, and I'm just going to put an n here. All right, so it says to add a slider, so I'm going to go ahead and do that. All right, and now I'm going to change this a little bit. I'm just going to go to 0. 0, 2, no, let's go to about 6. We'll just go by ones. Okay, so what this allows me to do is to step through things. So here I have y equals x to the first, which is just our linear, right? That's nothing exciting there. I'm going to move it to a 2. Now we get a parabolic or parabola, okay, sort of shape, which, and you should be familiar with that, all right? Then we go to a 3, and we get this sort of a shape. Then we go to a 4, and we get another sort of parabolic shape. And then 5 gives us more of this kind of a shape. So what do you think 6 is going to do? Right, we're going to get another U type of shape. Okay, so 2, kind of a U, 4, kind of a U, 6, kind of a U. So what's 8 going to give us? Right. So then you could be able to say, oh, okay, well then I know what's going to happen when this power is even. Now, if you did, also you might notice, here this is kind of nice, little bit of a pointy sort of a bottom, but then as I make this, see what's happening here at the bottom, okay, it's flattening out a little bit more, right? But you're still getting that same kind of shape, okay? 3 is this, 5 is this, so what do you think 7 is going to do? Yeah, it's going to give you the same kind of shape, okay? I'll get to 7. There it is. Again, it's just flattening out, all right? So, there it is. So we should write down here, if we have n is even, then what kind of a shape are we going to get? A U shape. Okay, and the domain for those U shapes is, what's our domain? The domain? All reals. Remember, so for domain, we're talking about x's, right? So if we kind of fold this down or collapse it down, it's going all the way up. So that's just going to be all reals. Now, what about the range? Yeah, everything above 0, right? Good job. Okay? So that's when we have even, all right? When it is odd, then we get this kind of a shape. I don't know how to describe this kind of, I usually just call it a swoosh, but I don't know what it is. So what's the domain of that one? Again, it's moving along. All reals, right? And what about the range? All reals. Okay, it's covering everything on the y-axis and the x-axis. So those are kind of called power functions. Now, they have different names, of course. So if this is a 3, it's sometimes called a cubic, all right? We call it a cubic. Again, a 2 is going to be a parabola. 4, sometimes they call that a quadratic and so forth. But mainly, I guess quadratic is 2. I don't know what they do. 4 is quint something, I think. But most of the time, cubic and this parabola ones are the only ones that they really talk about. The rest are just fourth degree or whatever. But so those are your power functions, okay? But, sorry, I'm switching back and forth here. This was only, excuse me, you notice that I made a step 1, all right? And I also started at 0. So if I go back and make this like a -5, Okay, then I get this type of a deal here. Okay, and these are also considered power functions, but they're classified in a different way. Okay, so they are also known as rationals, which we'll get to in a little bit. So they're, in our text, they're better known as rationals, but since they are in this form, they could also be considered a power function. All right? And if I go by point ones, let me get to a positive number here. So if I go by points, then I even get more crazier looking shapes. All right? I can see some things happening there, how that's moving inside. So those are also power functions when we have decimals for powers. That's also possible. But then they're classified as a different type of function. So power functions is a huge classification, covers a lot of different things that are kind of underneath it. So it's like a big umbrella, and then there's these other things that are underneath it. All right? Okay, so we did powers. Back to this. So these are the ones that are kind of considered powers also, but I'm just going to call them roots. So there's a square root where that's even, okay, and then there's odd roots. So let's explore those. All right, so we'll go back to this again, and we'll do the same type of thing. Let me get rid of this. So to get to the roots, I'm going to go to miscellaneous over here, and this guy right here, and I'm actually going to put an n in there, and then put an x here. Okay, and we'll add a slider. And I'm going to start at 0, and we'll go to about 5 again, and we'll just go by ones. Okay. Oops, I don't have a y equals there. There we go. All right, so I have y equals, okay, here's the power on the root, okay? So it's just a line, it's not a big deal. Okay, so there's a square root, even n. There's a cube root, fourth root, fifth root, sixth root. So again, the evens and the odds are looking different. All right? So what's the difference between our evens and our odd roots? Yeah, which ones are all negative? The odd ones are, right? Okay, odd ones are going negative. Okay. So, n is even. We get this kind of a deal. And when n is odd, we're getting this kind of a deal. Okay, so what about the domain when it's even? Good. 0 or greater. Okay, range? Same thing. Good. Okay, n is odd? Domain? All reals, good. And the range? Okay. Pretty dang similar to the other ones. Kind of get a little more of a flat in the over here in the higher you go, a little flatter in there. Okay. Those are powers, but they're called roots. Okay. So they have those ones. This one they call a reciprocal function, all right? But most of the time it's known as a rational. And it looks like this. Okay, so this one, now the crazy thing is that they do a lot of rational stuff in this textbook in the beginning, but then the rational functions are the last thing that you do in the class. So, I don't know, they kind of bring it up, but then they really don't talk about it till the end, so. Anyhow, this is a rational. That's what it looks like. And let's see, you guys show me how to do this table. Oh, that was over here. Oops, I know that. I should have known better than that. Okay. Where was that at? Where was that table thing last time? It's in the little gear thing here? Yeah? Oh, yeah, there it is. Thanks. Okay, got it. I don't know why I was going to show up too. All right, so here on the little table thing, all right, this is what it looks like. Okay, they got some points here. Notice that it's undefined at 0. All right, so this function kind of goes like this. It just never touches 0. We can zoom out. It looks like it does, but it never does. Okay, it's getting close, but it never does. Same thing down here. All right. And the reason being is because if you put a 0 in for x, what happens? It's undefined, right? It doesn't work. Can't divide by 0. So that's why it never touches 0. Okay? Everything else is okay, but it never touches 0. So now that we know that, we come back to this again. Domain and range. So what's our domain? Not 0. Okay? And the same thing on the range. Everything else is okay, but we can't have those. All right, so let's see. Powers. Rationals, which were really just underneath the powers. Okay? They called them roots. All right? And I'm just going to go through the ones that have. Absolute value. Okay, go back to this. I'm betting you've probably seen this graph. I like that table feature. Okay, so there's our absolute value. All right, absolute value, remember, negatives go to positives, right? Positives stay positive. Very similar to distance. So here we get a nice V shape. Okay, what is the domain going to be of that? What's the domain? All real numbers, okay? Again, we're looking at the x's. Okay? If I fold that v down, it's going to cover everything on the x-axis. All right, what about the range? Looking at the y's. Greater or equal to 0, okay? Yeah. When it's just in its general type form, yes. I really should be putting these in a different color. Just so it contrasts a little bit more with the axes. Okay? Yeah, because 1, so it's 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3. So yeah, get a nice 45-degree angle there. Okay? So we did, again, there's absolute value. All right, they mentioned that one in there. I want to put this one in. Y equals a to the x. So a is just some number. All right, some real number. This is an exponential function. So we get a bending sort of here. Okay, so if I start out at 1, I get nothing. Okay, so as it increases, I'm getting this kind of a look here. All right? So, and this curve is just going to continue to grow and expand outward. Just doesn't expand outward very much, but they're a little bit better feel for it. So, what's our domain? All real again. Okay? All real. We're good there. We fold it down, fold it down, fold it down. Goes way down over here. Okay? But this never gets to 0, although it says it does. Okay? Let's see if I can get it to be. There we go. And finally, what happens is that it loses its. See, there's 0.001 at about negative 80. See, finally it gets to 0. Well, it never doesn't really touch 0. It's just that it runs out of digits. It's only going to round it so long, and it's going to just chop it off. So it never gets close. It never touches 0. Okay. So an exponential looks something like this. All right. There we go. And the domain and the range. What's the domain of this, would we say? All real good. But the range is going to be what? Greater than 0. Okay. Greater than 0. So most exponentials are going to look like that. You know, for positive a values, or for, excuse me, a values bigger than 1. For a values of less than 1 but greater than 0, it's going to come downward. Okay, so you're going to get this kind of a... But the domain is still going to be all real, and the range is still going to be greater than or equal to 0. It's just in a way that it slopes. You would probably think of it up, down, that kind of thing. Okay. But that's in the next chapter when we talk about exponentials. Okay. So, but I'm just tossing it in there. All right, let's see. So we got that. I'm not going to do that one. I'm not going to do those. I think that's pretty much all the ones we need to do. Any questions on any of those ones? Not many questions today. Okay. So last week when we did the decimals activity, all right, and we took the eggs out of the carton, and you guys drew a graph for that. Do you remember what that kind of looked like? Stair step. Yeah. So it's something like this. Okay. So that's what we're going to look at now. All right. So we're going to go back into decimals here, and we're going to play with this a little bit. All right. So in here, we're going to go down here to y equals. Okay. And there's 2 of them we're going to look at. We're going to look at 3, but I think there's only 2 in here. So let's take a look at it. Functions. Okay, the one we're going to look at, oh, I'm sorry, there's 3. Seal, floor, and round. Those are the ones we're going to take a look at. Okay, so let's look at seal. And we'll put a X in there. So, there's the graph. What is this thing? How does this work? What's going on here?
So you're adding.
Let's go one at a time. What?
Last time it was going down because you were taking away. Now it's going up.
Okay. Now it's going up. Okay. So how are the x values changing exactly?
Or the y values are changing without like the gradual and fractional change. You count something at a time and the actual.
Okay. You have to.
Yeah, the y number is a whole number.
Y's are becoming whole numbers. Okay, so x's are all real, but the y's are whole numbers. Okay, that's an increasing going on. You had some
Increments.
increments.
Increments, like you just the dot.
Okay, so all these are great ideas. So let's think about. So then here's what this is called seal, right? And so we've got increments, we've got y's are wholes, we got an increasing thing, we got all kinds of ideas. Let's think about this. Let's say I put in here 2.5. Okay. So what does it do to the 2.5?
Still going to be 3.
It's going to be 3? Let's see if you're right. So if I go here, excuse me, here's 2.5 is going to be here. There it is. You're right. It's going to be 3. What is it going to do to 2.1? So what does this function do to those numbers? Rounds up. And where's the ceiling? Up. Okay. So Desmos calls this ceil because it says that it's taking these numbers and rounding them up. Okay. So ceiling is going to round up. I'll put this on the tablet too a little later. That's what ceil does. Okay. So it rounds up. So there's different type of rounding. It's just often we don't think about it too much. We always think about the rounding, the normal rounding, but there's actually different types of rounding. Okay, so there's ceil. Let's go to this one now. Y equals functions floor x.
I have a quick question.
Yeah.
Did you happen to draw this? I found it.
Nope, I didn't think so. No, I didn't. Floor x. So let's look at this one. It's the same? Looks the same. Still steps. But what? It starts at 0. Okay, that's a cool observation.
So assuming that the first one is ceiling, it rounds up. Floor means rounds down.
Let's take a look at it. So if we put in 2.5 again, right? Let's see what happens. So we go up here, 2.5, maybe.
Yeah, rounds down.
It rounds it down. Okay, floor is down, makes sense. Ceiling's up, gonna round up. Floor is down, we're gonna round down. Last one, y equals round. What does that one do? Yeah.
Round to either up or down according to whether it's above is equal to or above 0.5 or below.
So it falls in the down.
So 2.5 is going to go to, where's 2.5 going to go? 3, right? But 2.1 is going to go to, where's that going to go? 2. Yeah, so this is your normal rounding, so to speak. All right. Or actually, we call this, I should say, to the nearest. Okay, or your normal rounding. If you guys want to say that, that's okay. All right.
So what are the practical applications for the ceiling and the floor?
I was just thinking about that. This is probably going to ask that. So, obviously, this one here, right? This is kind of important to you because you want everybody to round up, right? And your grades and stuff like this. And this is kind of you can see where we use that. So, when would rounding up occur? Can you think of anything where that one might happen? Yeah.
If you want to like buy material for building something, then you always want it wrapped up so you have like more.
So when you're buying stuff for building, yeah, you want to have more, right? Okay. What's that?
Like pizzas for a pizza party.
Pieces for pizza party, yeah. Okay, you're gonna always have more. Okay. All right. Probably wish some of your hourly wages could have like that, right? Okay. Rounding up. What about rounding down? So there's some situations where you're actually charged by certain situations, like if you're 2.5 hours, but they only go by the hours, they may round up or down. Okay, you see some of that stuff. Packages, mails, kind of thing, sometimes are rounded to a flat rate or rounded down. All right, so it kind of depends. I mean, there are some applications for some of these out there. All right. Obviously, this one is pretty common. Okay, but up, down, nearest. Okay, some tax structures are like this. Okay, where they round different ways. All right. Okay, so we have, y equals floor of x, which gave us this little graph here. This one rounded down. What's the domain? What's the range? All reals for the domain, right? And the range is same, but we don't get fractions or decimals. So whole numbers are positive, but I understand what you're saying. We'll just say these are integers, because the integers are positive and negative whole numbers, right? Okay. So there's floor. And ceiling is going to be more like this. Same thing. Integers. And then round. See if I can do this one kind of right. So it's more like this, where the 1 is kind of in the halfway point. 2, 3. Okay. So there's our 3 rounding in decimals, all right? Now, in the text and in mathematics, all right, they have this thing called the greatest integer function. All right, and the greatest integer function takes on one of those things. Let's see if we can graph this one. I don't think it does it in decimals. So the greatest integer function is going to round down. Okay? it's symbolized by, they sometimes use this, or sometimes use this. I've even seen this sometimes before, okay? So it kind of depends on the textbook, okay, and what they're going to do. This one, I think they just used a little bar. They used the INT on there. But I thought I saw something different. Maybe that was a different book. Okay. Anyhow. Okay, so the greatest integer function, so that's just going to look a lot like the floor one is. So it looks like this. Okay, 1, 2, 3. Okay, and this is solid, and this is kind of an open deal. Oops, no, sorry, back up, hold on. I got it backwards. I got the bars right, I just got the things at the wrong spot. So we're solid in the beginning and open at the end. There it goes. And the reason for that is, and I haven't drawn this graph very well. There we go. That's better. Is because if I don't have, if this is solid, this is solid, then we have an issue because it's not a function, right? Okay. So this is open, which means it gets really, really close to 1. But as soon as it hits 1, it jumps up here to 1. There should be 1 here. Okay, and this gets really, really close to 2, but once it's 2, it jumps up there. Okay. That makes it a function. And the floor and the ceilings are like that too. We just didn't draw them that way. Desmos doesn't show it that way. But that's why they're functions, and we're able to get away with that. Okay?
So if you're to write the coordinates, would it be bracket 0, 1, parenthesis, bracket 1, 2, parenthesis?
For the coordinates of, like pick a coordinate out of there, is that what you're thinking?
Or with the union. So it'd be bracket 0, 1, parenthesis, union, bracket 1, 2, parenthesis, union.
So what are you describing here?
If you were to try to state the domain.
State the domain? The domain's still all real numbers. Okay? Because if you slide these down, it's going to cover everything on here. Right? But the range is going to be those integers.
That's not something else also.
All right. So that's called the greatest integer function. All right. And let's do one more thing and I'll get you a break here. So they also mention in this one paragraph, they talk about the difference between continuous and discontinuous functions. So a discontinuous function basically is this. It's the graph of a function. Well, let me do a continuous because it's way easier. So continuous is graph of a function can be traced if you, this is not a real mathematical definition, but it sure works. Graph of a function can be traced if you never have to lift your pencil or pen. All right? So in other words, mathematically what they're saying is that the graph exists upon each value of x. All right? So there is a y. So if I have a graph like all the ones that we were doing, I can trace this and never lift my pen or pencil. But as soon as I look at something like a floor or a ceiling, lift, lift, okay? So this one is continuous, and this is not continuous, or what we call discontinuous. Whenever I have to lift that pencil. Same thing with that rational one that we did. Lift to finish it, okay? They don't do a lot with that, but a little bit. Okay, so let's finish off 1.4 here. I'm going to give you some time to do a little bit of stuff here. So piecewise functions, all right? Kind of a different sort of a deal. So if we wanted to, well, let's piecewise functions are functions that are defined in pieces, basically. That's why they call them piecewise. All right, so if we have f of x equals normally this kind of a setup. All right, so let's say I go x negative x plus 3 and x squared, and let's go with x plus 3. I have no idea what this is really going to look like. So this has 3 different functions. Okay, and then usually there is a condition for each one of these. So it might look like this. So let's say that this part of the function occurs when x is less than or equal to negative 2. Then it does this part for values between negative 2 and 2. And then it does this part for values that are x is greater than or equal to 2. Okay, so it has a function part. This is the pieces. All right. These are the conditions that the function is defined by. So let's play around with it a little bit. So let's take a look at f of negative 3, for example. So if I have negative 3, right, then I look at my conditions. All right, which one of these does it satisfy? Okay. So x is negative 3, which one's it going to satisfy? Top one, right? Because it's less than negative 2. Okay. So then I would go to the rule or the piece of that condition. So then I would put negative 3 in here. So that's going to become a positive 3 plus 3 is 6. All right, so this would be equal to 6. So then negative 3 and 6 is on the graph. All right? Okay, so let's look at this. F of, now let's go with -1. All right, so then I look at the condition. All right, well, which condition does this one meet? Little one. Okay, so then I follow that function, that piece. So this would be -1 squared, which is 1. All right, then let's take a look at f of 1. What condition does that one meet? Middle again. So that's 1 squared, or 1. All right, and then f of, let's go with 3. All right, which condition does that one meet? The bottom one, right? And then we would just get 3 plus 3, which is 6. Okay? So that's how a piecewise function works. So it's broken down into conditions. All right? Yeah. No problem. So f of -3, so it fits this condition because x is less than 2. So then I put -3 in here. So negative of a negative becomes a positive, and then plus 3 equals 6. Does that make sense? Well, it meets this condition, so you only do this piece.
Oh.
Okay. So then, like this one met this condition, so we only do that part. Okay. Okay, so that's how a piecewise function works. All right, and you can, I mean, the conditions could be anything, the functions could be anything. It might be 3 long, like this one's 3, or it might be 2. All right, you can decide, or they decide what it is. It's hard to tell. So let's go and show you how this is done here. All right, so let's see. Now Desmos does this backwards, if I can remember correctly. You want to get those brackets. Okay, so the brackets can be found on the ABC, and here they are. Okay, so ABC, there they are down here at the bottom. All right, so in Desmos, and I don't know why they do it this way, but they do, the condition comes first. So we're going to go x less than or equal to 2, -2, and I believe it's a colon. Let's try a colon here. Colon. I think you have to hit the shift up to get the colon. There it is. So I had to hit this little shift up key to get the colon. And then we put in the function, which is -x plus 3. All right? Then we have to go comma. I'm almost sure of that. And then I got to put in a condition again. So that would be -2 less than x less than +2 colon. And then I put in the function, so x squared. See how it's making it? Then I'm going to go comma, put in the condition first, x greater than or equal to 2, colon, and then put in the function, which was x plus 3. So there it is. So the one thing you don't want to do is press enter. If you push enter at any time in here, it messes it all up. Okay, but that's what it looks like. All right, that's what it looks like. Yeah. That's not what you're getting? think you need a colon, you got a semicolon. Yeah, it's gotta be a colon, so you have to hit the shift. We go to ABC, you gotta hit the up. You got a colon now. Okay, choose keyboard. Okay, so that's a piecewise function. So notice that if I trace this, okay, I have to lift my pencil, so that makes it discontinuous. Right? And even though it doesn't draw a point in a circle here, okay, we know it's there because this would be our point. And since this function doesn't have an equals to here, and there's just an open circle there, then we're okay. All right? So when you draw this on your paper, so when you're drawing this like on your test next week or whatever, you would probably want to draw open, open, and then that kind of thing. Okay. All right. Yeah. Yeah, but only on your computers, right? Okay. So, let's do this. Let's see if you can, I'm sure you can. So let's make a simple piecewise function. I'm going to have you play around with this a little bit. Oops. Okay. Let me put this in a different color here, so we got this. See if you can make that. All right, so use a piecewise function. Take a few minutes. Well, you can take a little bit more, a few minutes. Well, we'll take a little time here and write a piecewise function to make that, that guy. Okay, and I didn't put any numbers anywhere. I left it open. All right. Okay, you just got to be able to see it. How about that? There it is. Okay, so write a piecewise function to make that guy. Okay, see if you can do that. So again, we're going to take a few minutes here and set this up. So I'll help set it up for you. So I'm going to go y equals I like using this, parentheses x minus c squared plus d, okay? And I'm going to do all sliders. So what you want to do is get c to be 0 in the beginning and d to be 0 in the beginning. So this is our normal parabolic curve right there, right? So then, once you have all those, just play around with the a's, the c's, and the d's, and notice what happens to the graph. Now, don't do them all at one time, obviously, because you're not going to get them separately, what they're doing, okay? But go ahead and play around with that, and then we'll go over it all together, okay? So this should take, probably take you about a little over 5 minutes to Okay, let's talk about what does A do? Yeah.
It widens or it, compresses the gap, and if it goes into the negatives, then it flips it.
Yeah, you're right about that. If A is less than 0, what'd you say?
It flips the graph over the, x-axis.
Okay. So we got widen or compress the graph. A is less than 0, it flips it over the x-axis. All right? And if it's 0, obviously it goes away. All right. So that's great. Anything else? So we call this a vertical. I don't know why am I writing this so. We call this a vertical stretch. Okay, so how can we call it a vertical? So what happens is that it takes the U shape and it stretches it. All right. Okay. Now, so we've also got compress. When did that happen? When did it compress it? Do you know what A values did that? I don't think about it. So I don't think when it got larger, it compressed it. When did it compress it? Give me an A value of compressor.
Further away from 0.
From what?
The further away from 0 gets the more compressed it gets. So it's like the widens out completely, flat at 0. The further negative you go, or the further positive you go away from 0, the narrower your travel gets.
Okay. So if I make this larger, all right, then we say this is this being stretched or compressed? Okay. I don't know. Well, it's maybe it's in the way that we're talking about it. Okay, so now I'm going to go from 0 to 1. All right. So to me, this is now it's just maybe in the way we're looking at it. I'm not saying you're wrong at all. So this is normally stretching because we're taking the graph and stretching it upward.
Oh, okay.
Okay, I think you're thinking of.
It's going infinitely this direction anyway, so think about that. Just that way.
Right, so we're thinking about stretching it. So if we took you and went like this, we're stretching you upward, right? So we're stretching you this way. But this is thought of maybe as a compression because you're pushing it downward. Does that make sense? So it's widening. You use the word widened, right? I think. Yeah. So it's widening. Okay. But what kind of numbers are widening for A's? Closer to 0. All right. Okay. So when we get some values close to 0, we're getting this widening going on there. All right. So we call this a vertical stretch. All right. So we have a vertical stretch, and I don't have any problems with what was said there. That's, you got to write down what you understand. Don't, if you don't understand what the heck I'm saying, ask, but if you don't, then write it in a way that you understand it, right? So we have a vertical stretch, and we also have a reflection, which you call the flip. So we have a vertical stretch and a reflection over the x-axis. Okay? So that's what A does. Widens or compresses the graph. A is less than 0, flips over the x-axis. There's nothing wrong with what that says. So if you want to leave it like that, so when you're answering questions on a test or in your assignment, and if you use the word widen, stretched, compress, well, let's see, widens and compresses is kind of the same. I think we want to put in here also maybe narrow. Too, if you're going to use those kind of words, all right? So narrow, I think I see what you're saying, compressing it this way.
Right.
Yeah.
I mean, the way that I was thinking about it is like, it's already going infinitely.
Mm-hmm.
You can stretch it
Mm-hmm.
in line.
Mm-hmm.
It would make a difference. So
Mm-hmm.
obviously you're compressing the line inward to make it narrower.
So I think it kind of, I'm not against, the thinking is correct, so I can't, that's why I don't want to say it's wrong.
I think I'll just say widens or narrows. Right?
Yeah, widens or narrows, okay. Vertical stretch, mathematically proper, okay, is what you're going to see in the text, and is what you're going to hear other teachers, if you take more math classes, talk about, or maybe you've already heard. So that's a vertical stretch. So you could, and then we would say by what factor it's being vertically stretched, okay? We'll do some examples of that. Reflection over the x-axis. Those are the types of things that we're probably going to hear more of, but there's nothing wrong with what we're saying there. Okay, what about C? Now, here's what we're going to do before we do that. Let's leave just a little bit of room for B, okay? C, what did C do? What does C do? Yeah.
It's the horizontal shape.
Okay. So it's a horizontal shift, right? So how many units does it shift? So if C, let me clarify the question. So if C is 5, how many units does it shift, and which way? 5 units to the right? 5 units? Okay.
C is the x value for x, right?
So C, here's C, right? So if you have x minus 5, you're telling me that it's shifting 5 units to the right, correct? That's what we're saying? Okay, that's good. So I'm going to say that a horizontal shift, C units. Okay, so it's a horizontal shift, C units. Now I'm going to come back to that. Okay, make sure we understand it when we do some examples here. D, what does D do? Up and down. So we would call that a vertical shift then, I guess, or up and down. How many units? So if D is 3, how many units is it going to shift? Up 3. Okay. So we got shift C units, vertical shift D units. B is the one I left open, because it's really hard to see B in this particular situation. In fact, in most situations. Now here, mathematically proper, okay, these are called translations. So we would say translated C or D units. All right, and like I said, I'll give you some examples of some of this stuff so we know how to use the language. I'm not going to get, if somebody says this is a horizontal shift or a vertical shift, I'm going to accept that because you're telling me the same thing. All right, so it's not wrong. All right, let's see if I can explain to you what a B does. I'm going to make this 1, and the rest of them are good. Okay, it's really hard to see a B because if we use B here, it's going to look a lot like A, except we don't get that reflection. Okay, looks a lot like A. So it's hard in a parabola to really see what B does. All right. So the best way to see what B does is to change this to a whole different function. To make it a sine curve. It's the easiest way to see it. So I'm not sure why we're not. Maybe it's got to be B times. Oh, because I don't have it turned on. Okay, so here's what a sine curve kind of looks like. Now, what happens is that it has a wave. All right, so it's kind of a wave. Here, let me put a number out in front so we get a little more dramatic wave. So there's a wave, okay? And so this wave, we would say is, let me get this to be 1. This wave is about 6, up and down. Up and down is about 6. 0, up, down. Okay, so it goes up, down, back up. Covers one wave crest, however you want to think of it. All right, in about 6. So, if I change this B, notice that it's compressing or stretching, okay, but this time not vertically, but horizontally, okay. And then, when it becomes negative, it's reflecting over that x-axis, or excuse me, y-axis. But in a parabola, you would never be able to see that because it's symmetric. Oops. All right, so you can't tell the difference. It just looks like it's the same thing as A. But that's what happens with a B, okay? So this is going to compress. So narrow or widen, you could say, also same thing, compress, narrow, widen, okay, stretch, all of it horizontally. Okay. Also, B is negative, reflects y-axis. So that's what B does. Okay, so here's what all of them do. If I can get it to narrow down here. I'm trying to get it to narrow down a little bit. Come on. It's not cooperating very well. All right. But that's kind of what they do. Now this does cause some issues for folks, okay? So let's do some, I said we were going to do some examples. Let me do some examples here. I want to change to a darker color here. What are they going to ask you to do? Okay? So the thing that they're going to kind of ask, and what I'm going to kind of ask, is to describe some transformations. Okay? Okay, so let's say we'd say f of x is equal to x squared. We'll just keep it as a parabola. Keep it simple in the beginning here. So then they have y equals, and here's how they're going to kind of do this a little bit. They're going to go 3 times f of x. All right? So what does that mean? That means this. Y equals 3 times x squared. All right, so what do you got to do? Well, you have to kind of distinguish and say, okay, is this my A, is this my B, is this my C, or is this my D? Right? So, what is that? A, B, C, or D? What do you think? A. It's my A. It's in front of the x squared. Okay, it's in front of it. That's what A is. A is in front of it. So, what does A do in this case? Stretch it. So you're going to say, hey, this is a stretch, but I'm going to ask you which way if you just put stretch. So which way? Vertical or horizontal? Okay, vertical. Okay, you could also say, well, you know what? This is going to narrow vertically. All right? Widen, whatever you think. You just got to tell me which way. So we're going to stretch vertically. All right? You could say by 3. That's a good thing to say, because that's the factor of which it's stretching by. Okay, so if we took me and stretched me 3, I'm going to be 3 times the size. All right? So I know it's a stretch. That's it. That's all we got to do. All right? Let's do this one. Y equals x minus 3 squared plus 1. Okay? Oh, sorry. This is going to be like this. That's what it's going to look like. Okay? There's no squared there. So it's going to be f of x minus 3 plus 1, which is this. Because f of x is x squared. Okay? All right, so here we go. We got a 3 and a 1 this time. What does 3 do? What is that? A, B, or C? C, very good. It's inside affecting the x. Okay? So, I don't have to bounce back and forth too much. All right. This is what we had. Y equals A, B, x minus C squared plus D. It's inside the parentheses. That's where C is. Okay? So, you know what's C? What does it do? Shift right 3. Very good. Shift right 3. And you could say horizontal shift 3. Nothing wrong with that. Okay? What is the 1? Okay, it's our D. So up 1 vertically, or vertical. Okay? Boom, done. All right? You're describing the transformations that occur onto that function. All right? Let's do one more like this. Y equals negative f of x plus 2 minus 3. Okay. I got all but b going on there. What do we got? What's one of the things we got here?
So you shift horizontally left to down 3 vertically, and it's a reflection of the
So we're shifting left, you said? How many units? 2.
because you always go the opposite.
You're right. See what he's saying? He says, you always go the opposite. And that's what messes everybody up. Because they look at this and they go, oh, it's a plus 2. So that means I'm going to shift right to no. Because it's a minus in here. So it's always the opposite. Good job. That's what we're looking for there. Okay, shift left 2 and what else?
Down 3.
Down 3.
And then I think this one is wrong, because it's a reflection of the x.
Reflection over
X-axis.
x-axis.
So we can say we're like shifting it left to down 3. We're always talking about like our reference point being 0, 0.
Yeah, because our normal parabola
Would be at 0.
was at 0, right? That's why I had to do that first one, so it's like this. Okay? So left 2, because it's opposite inside, down 3, negative 3, and reflection over the x-axis.
So when it's minus x, that's a reflection of the y-axis.
Yeah. Now, I'm kind of staying away from B's because they're really hard to detect. Okay, so if you're going to take Math 112, I know they do a lot. I believe I don't know if I taught it, but I believe they do a lot of trig stuff and some trig graphing. B's come in hand then you would really see your B's. Okay, so it's worth mentioning. So if you're going to do that, at least when that person gets to that point, you know, oh yeah, we did that in Math 111 a little bit. Okay, but I'm trying to stay away from giving you too many things with B's. All right. Now, that you did. Hey, you did that one. Great. All right. Here's the next part. Okay, so we got, let's do this. Normal curve here. Let me get some more numbers on here a little bit. So, there we go. There we go. Okay, I'm going to call this f of x. Here's what it's going to say. So what if we take this function? Now, I don't know what it is. And when you do these problems, you don't want to find it. Please don't do that because that's going to take a lot of time. Question's going to be this. Draw the graph of f of x plus 1. Okay. So we're just going to take this thing and we're going to shift it up 1. Good job. So what does that mean? So now I'm going to take some little reference points I got here, right? So here's like negative 3 and negative 2. So what's going to happen to that point? Where's it going to go? It's going to go up. It's going to go up where? So it's going to be negative 3, negative 1. So it's going to shift up 1. Okay? So everything is going to shift up 1. All right? So when you're drawing this, use some of those points to help you out. Okay, so then let's see. We got negative 3, so it's going to start there. All right? This one where it crosses at negative 2 is actually going to go where? How much? It's going to go up 1. All right? So I'm not looking for a super great sketch of this, but just something. I know that you're telling me that you kind of understand what's going on. All right? So see, we shifted it up one. All right? I mean, it's not a bad sketch. And that's what we're looking for. So we shifted it up one. All right. So we passed that. We're moving along here. Let's do this one. Negative f of x. Negative f of... Why am I getting a stupid green? Negative f of x. Let's just do negative f of x. I want to do it one step at a time here. So negative f of x. Okay. So now what's going to happen to this graph here? It's going to reflect over the x. Right. So basically what's going to happen is that this point, which is right here, okay, is going to go where? Well, where is this going to go? So it's going to go up there, right? So everything that's here is now going to go here. Where's this loop going to go? It's going to come down. Where's this loop going to go? It's going to go up, okay? So we're reflecting it. So you probably would be able to just about visualize this pretty well. So here I'm going to have this. So this part's going to come up here. Okay, and then I'm going to get a loop here which was down, but it's now going to be up. So it's going to look something like this. Okay, then I'm here, and let's see. I've got this part, so it's going to come to this. Then this is going to loop this way, and then we're going to continue to go, so it's going to look something like that. All right? So here to here to here. Again, it's not a great sketch, but I'm just looking to see you kind of understand the basic idea. Okay? How are you doing with that? We got that pretty well? Okay. It's going to get harder. A little bit. Let's do this now. Let's say I have 2 f of x minus 1, like that. All right? Now I have 2 of them at a time. So you say, well, how is that any harder? Well, because what do we do first? What is this thing going to do to the graph? It's going to move it over. And then what is this going to do to the graph? So the question is, what happens first? Does it do this part first or this part first, right? So we got to know what is it going to do first, because that could change the answer. So let's talk about it for a second. So let's say that we made a chart, okay? X, Y, negative 1, 0, 1, 2. It won't take us very long to figure that out. So negative 1. So I put negative 1 in here, and what does this do? It becomes what? Negative 1 minus 1? So what are we doing first? We're doing this first, huh? After we get negative 1 minus 1, we get negative 2, and then what do we do with it? What do we do with that? Multiply it by 2. So you see, we're doing this first, then that. Okay? That's the first thing we do. Okay? So, and this is squared, because I remember I don't know what this function is. So it's going to take this thing, and it's going to subtract the 1, make it a negative 2, and then multiply by 2 to give me negative 4. All right? So that's what it's going to do. Okay? All right, now that we know that, we're going to go and take our graph. I don't know what the function is. I don't care about what it is. All I know is the first thing I'm going to do to it is I'm going to shift it. Which way are we going to shift this thing?
Right.
the right. How many units? 1. Okay? So I think that's what I'm really going to do. Okay? I'm going to take it and I'm going to shift it. So over here, here we go. So I'm going to take this thing, so this is going to shift to there. This is going to shift to there. This is going to shift to there. All right? This where it was 1 is going to shift to there. All right? This negative 3, which was about 2, negative 2 is going to shift to there. All right? So everything's going to shift over just a little tiny bit. So I'm going to get something that looks like this. So it's shifted over. Okay? But you're saying, wait, that's just the shift. What else we got to do with it? We got to stretch it. All right? So, but I think it's helpful that you do one of them and then you say, okay, now, you know, especially if you're doing a pencil, right? So now what I'm going to do is I'm going to stretch it. Okay? Now I'm going to stretch it vertically. So this point is going to come down here. All right? It's going to be twice the size. This point is going to be twice the size. This is going to be twice the size. And this is going to be twice the size. So it's going to look something like this. Okay? So it's going to be stretched vertically in both directions. All right? So you kind of got to show that. All right? So it's tricky. These ones are tricky. Okay? In that, and I've seen people mess this up, that they don't do the order correctly or they don't do the stretch correctly. And you got to stretch it. Okay? You got to stretch it out in both directions. And you have to be kind of aware of what this number is. Because here it was 2, well now it's 4. But if this is a 4, this is now 16, so it's way down here. And so you kind of got to be careful with that. All right. I think I covered every single thing that you're going to get questioned on the test and on this assignment. All right. The only other thing that they have some matching, but that's easy to do. The only thing that they do that I didn't say anything about is they have a question where they say, write the equation, but I think you guys will be able to do this without any problem. Write the equation, and I know I'm going over here, sorry. Y equals, let's just do square root of x. And then they say it's shifted right 2 units. So then all you have to do is go, okay, shifted right 2 units. That's my C. So I'm going to write y equals square root x minus 2. Notice that we put the square root in the 2, so the 2's underneath it, because it's affecting that x. All right? If it's shifted 2 units right, all right, that's that one. And then let's say I say or and shifted 4 units up, then we would have y equals square root of x minus 2 plus 4 on the outside of the square root, because that's your d, and d is on the outside of the function, sort of. Okay? So you kind of got to be thinking about that a little bit when you're doing it. Whew. I hope you kind of get that. Any questions on any of that transformational stuff? Okay. Man, it's time for me to not talk for a while here. Okay, let's do this. Switch to this. Not real convenient, but it works. So we have a cylinder or a sphere. We have this cylinder inside. Looks like this. Okay. And h is the height of the cylinder. That's H. Big R is this radius of the sphere, and little r is the radius of the cylinder. Okay? So if you can picture a ball and a cylinder inside, that's what this is. So the volume of a cylinder is this. And what they want us to do is write that same volume, but in terms of this big R. Okay? So we have a triangle here. Like this. Okay? And this is big R. Okay? And this is half of an H. Hopefully that kind of makes sense. Okay? Because the whole H is this whole distance here. Okay? This is the center of everything. So this is be half of an H. So this is 1/2 an H. Okay, that's 1/2 of an H. So this here is the little radius, okay, of this cylinder, okay, right there. So they say note this right triangle because that's important. So the H, we want to solve for that. Since this is a right triangle, I don't know if you remember, you're familiar with, most likely, because you've had a lot of a squared plus b squared equals c squared in your mathematics career someplace along the line, all right? That works in a right triangle. So C is always opposite that 90-degree angle. So I want to put a big R there. The other two, it doesn't matter whether they're A or B. So I'm going to make this little r here, and then put this guy like this. So this is 1/2 H. So it looks like that. Okay, so I'm hoping you kind of see what's going on. All right, so here's the volume of the cylinder. They want us to change H. So it's written in terms of this big radius here, R, which is the radius of the sphere. Okay, so then they focus in on this right triangle where we have this distance, which is half of the whole height, 1/2 H. This distance, which is the radius of the cylinder, right there. And this big radius, big R, radius of the sphere. So then I used a squared plus b squared equals c squared, because that's what works in a right triangle. And then just put in those things. So this r squared is going to stay. This is going to be 1/4 h squared equals big R squared. So we want to solve for r squared. So we're going to move that stuff over to the other side. Okay, so I'm going to get r squared is equal to big R squared minus this. And then to get rid of the r squared, we're just going to square root. So there's my r. Okay? Now you think you're almost done, but well, not quite. So now what they want us to do is take and go back up to that original thing up here, right here. All right? And we're going to put that. Oh, we're supposed to solve for h. My bad. I screwed the whole. Gosh dang it. I thought we were solving for r. That's okay. It's not that bad of a deal. All we do is take the big R squared, move the little r squared over there. Get rid of that 1/4 by just multiplying by 4, and here it is. And then square root that. So the process is the same, it's just this is what we end up with, okay? So now I would take that, okay, and put that into my formula. And that's what they want, okay? Yeah, we can go back to whatever you want.
I think that's where you ended up with 1/4 each.
I don't know, I'm not getting much. For some reason, I'm trying to make this smaller so you can see things, but, and then this stupid thing comes up and messes everything up for me. Okay, let's go back to this triangle here. So here is the triangle. Are we good with that part?
Yeah.
Okay, so then I'm going to use a squared, b squared, c squared on this, right?
Yeah.
So this is r squared, that's my a. Okay, I'm going to make this my b. So it would be 1/2 h squared equals c squared, or big R squared, sorry.
Oh, okay, then 1/2 squared is what?
So the 1/2 squared is 1/4 h squared equals r squared.
Got it, okay.
Okay.
I got confused because it's still squared.
And we were solving for h, so then I just took the r squared minus little r squared, and then, yeah, you just multiply by 4. Okay, so I got h squared equals, I think I just botched this whole thing up here. And then we want to square root this. I think I botched this thing up right from the very beginning. Anyway,
Got it, okay.
that's what it should look like. So when you put that in, I think that's what they got.
Right, okay.
Yeah. Okay. There's my age. So that's what these things are about, and that's why I didn't give you very many of them, because they're really kind of a goofy problems. But 20 and 21 are kind of in the same, right? And then what did I give you? 8 and 9, 7, 8? 7, 8, and 10, okay? Those ones are actually a little bit easier because they're two-dimensional things, okay? So I didn't give you very many of those because they're just not very fun problems, and they don't, I don't know. They're not really applicable. We should do some things that are a little bit more interesting, I thought. So there's some of those, and then on the test, I don't anticipate putting anything like that really on there. If I did, it'd be something pretty straightforward, okay? So work through them best you can, and if you have questions, just ask me next week, and we can go over some more of those, because I'm anticipating there might be a few questions on some of those.